Today we're going to be looking at dividing polynomials. We're going to use long division to divide polynomials. So we're going to take the quadratic 4x squared plus 24x minus 16 and divide it by 2x plus 5. So we're going to put 2x plus 5 outside of the divisor house, and then inside we put 4x squared plus 24x minus 16. To start off, we want to know how many times will 2x go into 4x squared. So what do we need up here that when multiplied by 2x will make 4x squared? So 2 goes into 4 2 times. X goes into x squared x times. You are not concerned with the plus 5 or any of the other terms. You're always taking the first term into the first term. So then we multiply. 2x times 2x makes 4x squared. When you multiply those two, you want this term to always be the same as the one it's underneath, the first term. Then we'll create the second term by doing 2x times 5 and getting plus 10x. If you remember from long division, we now need to subtract this answer we got after multiplying. So 4x squared minus 4x squared cancels that term out. So now we have one less term. Then 24x minus 10x makes 14x. This is now our new first term. To get our second term, we bring down the second piece, or the third piece, which is negative 16. Then we do the same process again. How many times will 2x go into 14x? So what times 2x will make 14x? And that would be a plus 7, because 2 goes into 14 7 times, and x goes into x once. So when we do 7 times 2x, it will make 14x. Then 7 times 5 will make plus 35. Then once again we subtract this, and it cancels out that first term again, which is always your goal, is to cancel out that first term. Then we do negative 16 minus 35, which is going to make a negative 51. This is our remainder. So we find that 4x squared plus 24x minus 16 divided by 2x plus 5 is going to equal 2x plus 7, remainder, negative 51. And this would be the final answer. Let's look at another one. Let's divide x cubed minus 13x minus 12 by x minus 4. Notice that in this polynomial we are missing the x squared term. So when we go to put it into our long division, x minus 4 goes outside, but inside we're going to do x cubed plus 0x squared minus 13x minus 12. The 0x squared is a placeholder for what is missing. When you divide, every single term has to be represented to go from 3 to 2 to 1 to none. Since we were missing one of them, we put it in as a 0. So now let's divide. How many times will x go into x cubed? And that would be x squared times. So that x squared times x makes x cubed. And x squared times negative 4 makes negative 4x squared. Now let's subtract all of this. Remember, you always want those first two terms to be the same after you multiply. Then when you subtract, they should cancel out. Then we do 0x squared minus a negative 4x squared. Minus a negative is going to make it become plus. So this becomes a 4x squared. Bring down the next piece of negative 13x. Now let's do it again. How many times will x go into 4x squared? We're going to pretend that there's a 1 in front of this. So 1 goes into 4 plus 4 times, and x goes into x squared x times. So that 4x times 1x makes 4x squared. Then 4x times negative 4 makes negative 16x. Once again, our first terms are the same after multiplying. So then when we subtract them, that first term will cancel out. Then we do negative 13 minus negative 16. Minus a negative 16 is going to make it plus a positive. So we're really doing 16 minus 13x, which makes 3x. Then bring down our final term of negative 12. So then our last step is to find how many times x will go into 3x. We already have the x there, we just need the plus 3. So that 3 times x makes 3x, and 3 times negative 4 makes negative 12. So now, once again, we subtract these, and that first term will cancel out. Then we do negative 12 minus a negative 12. Once again, that will become plus a positive 12, which leaves us with a remainder of 0. Whenever you have a remainder of 0, then that makes this binomial a factor of the original polynomial. And what we have left after dividing is x squared plus 4x plus 3, which you could then go on to continue to factor. What are the factors of 3 that make 4? 3 times 1 and 3 plus 1. So we bring down the factor that we originally have. It is only a factor because we had a remainder of 0. So we bring down the original factor, and then we bring in our new two factors, which would be x plus 3 and x plus 1. And this creates our 3 linear factors of the original problem. You can only do that if the remainder is 0. Let's look at synthetic division now. Synthetic division is a different way to divide, but it's a little bit easier than the long division. For synthetic division, you start out making half of a box. In that box, you're going to put the 0 of the binomial that you are dividing by. So if I was to set this equal to 0 and solve, I would find that x equals negative 2. So I'm going to put negative 2 in the box. Next to the half box, we put the coefficients of the polynomial we're dividing into. The coefficients here would be 1 for the first term, negative 14 for the second term, positive 51 for the third term, and negative 54 for the fourth term. Once again, you want to make sure that every single term is being represented. X to the third, x squared, x, and no x. If any of them are missing, you would need to fill in a 0. For synthetic division, you're going to drop down the first number. So I bring the 1 straight down. Then I multiply. Negative 2 times 1 makes negative 2. Then I combine these two. What does negative 14 and negative 2 make? It makes negative 16. Then I multiply again. Negative 2 times negative 16 makes positive 32. And then again, I combine. What does 51 and 32 make? And that makes 83. And then I multiply one more time. Negative 2 times 83 makes negative 166. And then finally combine these last two. And it makes negative 220. This last number will be your remainder. Since it started out as an x cubed polynomial and we divided out an x, then it becomes an x squared. And these numbers here are the new coefficients. So from the 1, we gather that the first term will just be a 1x squared. Remember, since it started out as an x cubed and we divided out an x, everything gets reduced by a power. The next term is going to be a negative 16x. And the final term will be a plus 83. So we go from x squared to x to no x, with a remainder of negative 220. And this would be your final answer. Since there is a remainder, this original x plus 2 was not a factor, and I cannot continue factoring the new polynomial. So it would just stay as is. We use synthetic division for the remainder theorem. The remainder theorem means that whatever the remainder is will be the answer to if I had taken 3 and plugged it in for every single x and solved it out. So if I want to know what p of 3 equals, I'm going to use synthetic division and my answer will be the remainder. So once again, to set up the synthetic division, we make a half box. In that half box goes this number. Since it already gave us the 0, we're just going to put 3 in there. You do not need to do the opposite when it gives you the number. Once again, next to the box, we're going to put the coefficients. We start with x to the 5th, which has a coefficient of 1. After x to the 5th, we should have an x to the 4th, which we are missing, so we'll put in a 0. After x to the 4th, we go to x to the 3rd, which has a coefficient of negative 2. After 3, we go to 2, which again has a coefficient of negative 1. And then from x squared, we would go to no x, which again we are missing, so we put in a 0 placeholder. And then finally our constant, which is 2. Same as before, we're going to begin by dropping down that first number. So we drop down a 1. Now let's multiply. 3 times 1 makes 3. Combine 0 and 3 to get 3. Multiply again. 3 times 3 makes 9. Combine these two and you get 7. Continue multiplying by this number up here. So 3 times 7 is 21. Take away 1 and we get 20. Multiply that times 3 and we get 60. 60 and 0 makes 60. Multiply that by 3 and you get 180. 180 and 2 makes 182. That last number is your remainder. So P of 3 will equal 182. That concludes your lesson for today. So go in, print out the assignment, and try the problems on there. Bring your questions in tomorrow.